All right, let's get right into it. We're going to tackle the IB Chemistry internal assessment. We'll break down the whole thing from that very first spark of an idea all the way to a polished, high-scoring final paper. You know, picking your IA topic can seriously feel like you're searching for a needle in a haystack. If you're feeling a little overwhelmed right now, hey, you are not alone. But honestly, with the right game plan, you can turn this thing into one of the best parts of your whole IB experience. And it's a challenge that is absolutely worth taking on. I mean, this one project makes up a whopping 20% of your final IB chemistry grade. That's true for both standard and higher level. So nailing your IA, that can literally be the difference that gets you the score you're aiming for.
So before we get into the how, let's just make sure we're clear on the what. What exactly is the IA, and what are the examiners actually looking for when they're grading it? Let's get down to basics.
Okay, so this is way more than just your average lab report. You got to think of it as your own personal science journey. You are in the driver's seat for the entire ride, from coming up with a question to figuring out what the results mean and looking back on the whole process. Now, what I find really fascinating about this breakdown is how the marks are spread out. Just look at how much weight is on exploration, analysis, and evaluation. It's so clearly not just about getting the right answer. It's all about the quality of your scientific thinking and how you go about the process. And here we are at what is probably the most critical step of all, finding your question. This decision right here is the foundation for your entire project. If you get this part right, trust me, everything else just falls into place so much more easily. Inspiration is everywhere, really. Just think about what sparks your curiosity in the real world. Is it the chemistry of the food you eat? Or maybe environmental problems? Or even the materials that build everything around us? The key is to start with something you genuinely find interesting. So here's the bottom line. Pick a topic you're actually invested in. Your passion is going to shine through in your work, in your creativity. And that is exactly what the examiners are looking for when they grade you on personal engagement. This slide just perfectly captures the most important transformation you have to make. You've got to go from some vague area of interest to a super focused scientific question. And notice, the focus question isn't just more specific, it's basically a blueprint for your whole experiment. It tells you exactly what you're going to change and exactly what you're going to measure. Here's another fantastic example. I mean, the weaker question is an okay start, but the stronger one, that's scientifically solid. It clearly points out multiple things you'll change, the temperature and the pH, and exactly what you'll measure, the oxalate concentration. This is the level of focus you need for a top-scoring IA. All right, once you've locked in your research question, it's time to put on your architect hat. You need to design your scientist's blueprint, a really detailed, solid plan for your experiment that's going to make sure the data you collect is reliable and valid. Okay, this blueprint is your path to results you can actually trust. Identifying your variables in step 1 just sets the stage. A clear procedure in step 2 means someone else could repeat your work, which is the gold standard in science. But let's really zoom in on step 4. Why is getting enough data so critical? Well, because a single trial could just be a random fluke. But 3 trials, that lets you calculate averages and uncertainties, proving your results are consistent. And 5 data points across your range, that's what lets you plot a meaningful graph and see a real trend, which is absolutely essential for high-scoring analysis. Just knowing about these common mistakes can save you so much trouble down the line. Always check that your school actually has the equipment you need. And please, design your experiment to measure numbers, not just things you see. Avoid subjective stuff at all costs. And now for the really fun part, taking all those raw numbers and making sense of them. This is where you turn a table of data into a clear scientific conclusion and really show you understand the chemistry behind it all. So your graph is really the star of the show here in your analysis. It has to be perfect, labeled axes, units, error bars, the whole shebang. But don't just drop the graph in and walk away. You have to spell out the trend it shows, and then connect what you found back to actual chemical principles. Okay, now for the section that really separates a good IA from a great one, the evaluation. You know, the true mark of a skilled scientist is being able to look at their own work critically and honestly. So, you have to ask yourself this question. This right here is how you score big marks on that evaluation criterion. A vague comment like, use better equipment, that's totally meaningless. But look at that specific improvement. Naming the colorimeter and explaining why it's better, that it reduces subjectivity. That shows real scientific thinking. You're not just pointing out a flaw, you're offering a concrete solution that improves the data. That is the kind of critical insight that earns the top marks.
Great science needs great planning. To pull all these pieces together, you need a solid timeline. So let's look at a practical way to manage your IA from beginning to end.
Now, I know this timeline might seem kind of long, but trust me on this, every single stage takes longer than you think it will. Breaking it down like this turns one giant, scary deadline into a bunch of smaller, manageable steps. Your brain needs time for ideas to kind of simmer, and you absolutely need a buffer for when an experiment inevitably goes wrong. Following a schedule like this isn't about being rigid. It's about giving yourself the time and space to do your best scientific work without that last-minute panic.
At the end of the day, your IA is so much more than just a requirement. It's your shot to explore a piece of the chemical world that you find fascinating. It's a chance to ask a question, hunt for an answer, and tell your own unique scientific story. So, what's yours going to be?